Okay, welcome again. Making another video, just currently bringing in a lot of C# scripts that I've worked on. Here they are. I'm dealing through the methods right now. This method has been brought in by Github repository that I've made available. I'm not really making any of these private yet because the scripts are so basic. This is a return symmetry plane given 3 points. It's written by the Warsaw C# white paper. Pretty interesting. So we could just kind of go in here and call this symmetry page. Let's call it something similar to what it was. Return symmetry plane. So with that, and put that into the. This is just so I can have a GH file that actually jumps right to a GitHub repo that's public. And what I'll do is open that up. I don't know. Right click, put it here, and return symmetry plane. Let's save this kind of underscore S and underscore P. This is what I do in the evening when I get home from work. I get to all things that I'm pretty passionate about. And so you can grab 3 points. Grab this point, which is interesting. I can just generate, I guess, 1, 2, 3, and take that one, then lower it down, take this one, raise it up, and maybe that's the best way to do it, just set this point. I want to take this off, obviously. Actually, it might be interesting to make this point in the middle. This point can actually become this point, and this point. This point can actually become this point, second point. And we have a symmetry column that's being built, and I just want to make sure that plane is there. It's dependent upon this, and that plane is moving. It's just all that small. And what we're looking at, driven by those 3 points, and it's a pretty nice little function for doing exactly what it does. So once you have it up and running, just disconnect it, and what's nice is this is ready from GitHub. Take 3 points. I've named it a little differently for this script because this will be my master script. And we'll just kind of keep plugging through it. That's it. I'm just using all this variety of params and this panels to get at the content. And what I've done is I've written some very basic scripts and hopped them up. I've got a little hop crazy up here. Probably don't need this as reference. Same thing here. I hopped up a whole bunch more. And they're definitely ready to go. I didn't name them because they're so simple to see that the iterations less than will break. So it's kind of like beginner scripts in Python or in C. These happen to be C. And these are do while loops and they'll function. So I'm just making my own custom nodes that actually run from the hops node but reference somewhere from GitHub the path of where this is coming from. So if you get a copy of this file, you're actually depending upon the GitHub repositories that I've built, which is pretty exciting. And I can show how to hop to them. So in case you lose your node, you can just hop to it again. It's not too hard, and you can also name it. So that's what I'm doing. I'm just kind of hop to it. C# scripts on GitHub. Luckily, I spent a lot of time making Python scripts and C# scripts last summer. And so it's all coming into play and pretty interesting to figure out. So our next one that I wanted to get to is called array from start end values. So since we're going to be getting rid of a lot of these, let's just slide that one down into here until we get it working. We right click, we go to path, and we have to find that path. So I'm going to go into my open repository on GitHub. Go on down to the 1M method I was thinking of using, which was array start end values. Right click and grab the link. Take that one off. Paste that link in here. Get it up and running. Just takes a second to jump to my GitHub. There you go. You get start end value. That's wanting a point, I believe. So we can grab this one, and maybe we can just default to. Let's just grab another point. Actually, we just grab any one of these. Let's grab that one. Go to endpoint. And it's an integer value. Sorry. Okay, so that's going to make sense. We got 4 all the way up to 7. And then in array is going to be 4 to 7 is an integer array. Now that's not really something that I care too much about as a method. I mean, it is a method, it's written in C. I just don't think I need something that simple. So let's just cut down that. Say it's not really worth bringing into this kind of master script of micro plugins, micro C# plugins to drive some very interesting geometry. This is an example of enabling and showing. It takes a second to learn all those scripts because that can jump to GitHub. I have 1, 2, 3 in here. Just give it a moment. There you go. And it produces a pretty fast geometry that I think optically is a very exciting form. I like what it does. And that is running by a basic grid of 3.3 points with a for each loop that has a little problem happening, probably because of just some data coming in from X, but it still is running. And I'm putting it through a clean tree and then into subdivision. So actually it's just 2 GitHub hot scripts coming from this path, which is a for each loop on the GitHub, and the other one is a grid. And you don't have to get in there and know about the C, though the C scripts can be found as user objects, an array, grid of points. That will be something similar probably to this one. So I've written a nested loop. And that's right, this is for people who want to use C in Python script, but maybe don't have a real interest. And this will get more and more complex as we get into something like the Rhino geometry white paper by ISA, which can be very interesting. There it is, which will do points all the way through the reps. At that point, I might start, well, since it's open source, just keep it open source as long as I can. There's no reason not to. And that little C script that I need, you can always reference those on my GitHubs that are available. I'll take that to disable. And let's keep rolling. So the next one after that was called Ideal Elastic Bounce. And I don't know if that one was word. I had trouble with the vector bringing it in, but actually let's take a look. Ideal electric bounce, which is an M method. There it is. Elastic bounce, electric bounce. Copy the link, close it up, grab yourself a little hops node, right click, set your path, and give that a second to go to ideal bounce. What does it want to do an ideal bounce? It wants a vector. Here it is, speed vector. I have to bring them in as numbers because I cannot import any vectors as of yet, even though I can output bounce vectors from displays, which is interesting. And the reason that is the params and the hops up nodes don't have get vector yet. I can't even find get boolean, which I think was there a while ago. So basically displaying a vector from display, bounce vector display. You can see kind of what's happening small in there. There it is. There's the bounce vector. They'll get rid of these other objects. Well, they're not bothering me. There's just a little bounce vector there. And I want to know the speed of that vector in one direction, the other direction, the next direction. Let's just have some fun. And they do get a little out of order, so you have to look at the normal here and then the speed vector. So that's one problem with the hops, is it kind of jumps around. So what I'm doing is just grabbing a bunch of numbers just to produce some vectors, just for fun. And we'll just get number 12 here. So we've got this kind of strange double vector happening, and of course you're losing track of your, these are the visuals to bring in what was coming in. So this vector right here is informed by this vector here along the ground, and that's an ideal bounce that's happening. So a local why did I call it local normal? That's what it is, local normal vector. Let's see what that one looks like. It's more related to that. So vectors can be pretty interesting, and I think it's somewhere tucked around. There it is. So this one, vector at that speed, will produce this kind of bounce. And it's more of a simulation. I don't know who would use it. It's a pretty clumsy node, but it does produce 3 vectors by 6 numbers. So you can have story control as you move that through. Let me see what happens as I play with these. Those are scaling, so that's probably a little different there as you get scaling of those vectors. And then let's see if I can get a type of rotation happen. There we go. So maybe, and it's interesting that that little point is obviously changing in reference to that, but I'm building kind of, let me show you what's happening here. I'm just playing off a little bit of data. Assume extends all. see what we end up getting. These vectors are playing off different directions as an ideal balance to what would happen if you drop. So it's kind of a cool thing to play with a simulation like that. I don't know. Maybe I'll hold on to it. Maybe I won't. Grab the path and grab ideal elastic bounce. I'm not sure if we'll use it in one of my scripts. It does get me thinking C a little bit. I'm going to jump in here. Ideal elastic bounce. And I do like the underscores now. I'm changing how I use camel case or pastel case. That's it. Elastic bounce. Why not? And this is a slippery slope when you start getting into this, and you work slow at it. But now I have to disconnect all these awesome things because this is not really it's not really convenient. I think I'll just get rid of that. Those displays over. I'll just post that. Get back to normal ones. So there's another node that I might use. They're getting a little more complex because they're methods, but are making code a little differently. Let's grab another one, see if we can do something with it as we move along. I kind of wanted to finish up the M and N and P. I think we'll just finish up N with a class point 2D and a class particle, which is actually going to relate to that one. So let's jump in here. Let's go back in here and grab the N values. I think the 2 and N that were interesting are both these. Class point, which is pretty much like a grid, so it's not that exciting. But I have learned how to script a little bit and run common in C#. Thank goodness off of these white papers. And I think it's just a matter of time before things get more and more interesting. So we'll jump in here and grab this path, class point. Actually, before we do it, I'll grab class point 3D. And that way I can go in as it's running. Click here and put it in class point. Once again, I'm going to take it out of that Pascal case, get this back into class point 2D. I'll give it a title. Let's get it up and running and see what we have. So it's kind of nice. It's just a X coordinates that pop out. There's an out that says something because I left it in there, so it must have some to come. I think it might be a list of numbers. I'm not sure, but maybe not. It might be an array. What is that saying to me? Failed to collect data, obviously 2 by 2. You've got my point at 2 and 2. Get rid of these if I'm not using them. And you can see those X coords are 2 and the Y coords are 2. So it just gives you back out what you had. It gives you a Y point. So not really anything of value. The script is there if you want to access this other data. So W as methods, class points. No, it was N, so it was this one. Class point 2D. If you want to see what actually that script is generating, here it is. It's literally just drawing a point graphic, so it's not anything complex, and it's certainly not a node worth spending too much time on, so I would get rid of it. We'll go back in and see what we can draw in this here, which could be nice. So I'm going to leave that one off, and then I'm going to go to class particle and see what I was thinking. It's not like every one of these is going to be useful for dealing in Rhino, at least in my mind, so you have to have some sense of what your projects are or what you want to do with it. At this point, I'm still learning an awful lot, so I just want to play around with this. Copy that link, go in here, find the path, type it in, so you don't need the user objects. It's class particle. Take that, copy, OK, give it a second to run. It'll load up. This one's pretty exciting. It needs a velocity vector, and it needs a number for acceleration. What are you going to accelerate to? So if I accelerate by 1.2, that's going to slowly get faster and faster and faster. I need a certain velocity to start. I think I'll just start at velocity 2 vector and 2 and 2 in that direction. Particle location, I'll probably begin that particle at 0. I think also I'll go back in here and just grab the path. Okay, I already did that. I think I'll just go in here and give it that title. Class particle. And it's kind of moving something, so it started at that particle location. We do want the boolean to run, which you have to treat as a number slider or a boolean. So we'll say yes, we want you to run, and yes, we want to reset it. And then we should have a vector coming out. Because we're going to get a vector, we're going to get an acceleration number saying you're moving at 1.2 because that's data in. Current position is where it starts, and then the vector is where it moves, the particle velocity out. So I'll probably have to grab a display vector for that. You could take that, take that vector from the current position. And there you go. That's the acceleration out. So as I start to play with this, move that acceleration out, the thing has to move accordingly. So it is a little bit of a, now it's going to fly very fast if I run it. And I think I can run the simulation by, this might make more sense if I grab a Boolean toggle, and do that twice, and give a way to reset and then a way to run. So we want to reset, and we can take a look at this vector out, and we want to definitely have it run. So we're going to have it run, and reset, true, and run. There you go. That's it. If that was to take off, that's exactly what it would do, and that would be the speed that it's moving off at. So we reset it, and then we activate it, and it runs. And I think I could just run it like that. Yeah, there you go. It will run, and it also depends on this data. And this can really change fast if you start playing with these numbers. So we'll reset, and let it run. And sometimes this can be a little wild where it ends up going. Velocity vector is moving off, obviously, and what it wants to move, and it's tied to that acceleration. The acceleration really explodes out of the way, so it's hard to grab that. Hard to see that whole simulation as it goes. You kind of see how that would speed off differently. So yeah, it's a little class particle simulator. Kind of cool. I mean, to get your head around it and think of doing it. I'm going to put it in there anyhow. And what I'm going to do is I'm just going to take that back to class. Particle, and that's it. So it's nothing too fancy. I've set my little video tutorials in the evening for an hour max. I don't need to bore people. It's how I'm thinking. And then I'm going to wrap up with Point Tower, which was this nice one. This actually makes a nice little point tower for enable, and it's trying to run as it is. This is a fun little point tower. I'll put it in here to show you it's working. Let's say the height was set to 12, right, and spacing is set to 2. I have a seed that I can adjust it by. Just so happens I like taking the number slide 12 and the amplitude 1.66. Let's see what we have as a point tower. Grabbing yourself some points. This is what we've generated as a geometry. And keep in mind it's writing to C-script. And there it is. Got a nice little point tower that I can interpolate through and have some really nice effects of generating something. A nice little script. I actually really like this one because I'm a sucker for a little bit of chaos, and let's just grab a little bit of one of my favorites is a nerves curve, and there it is. So you get a crazy nerves curve that's informed by this data. Pretty exciting, and we'll see how that has an effect on it. I have to wonder why my curve's not coming through my other screens, but really nice little point tower, and I like seeing it from the top as it generates some wanders off and does some crazy stuff as well. I really do like this geometry, so we've got to play around with it. Anyway, I'm probably going to finish up with 2 more scripts, number sorting and bubble sorting exercise. Let's go through it. Let's just do it. This one down here, and we'll have one more after, just to make 2 more. So back in here, let's grab what I prepared as this first group. Through this war sellers the point tower, there's the number sorting. Let's right click here and grab the copy link, close that up, right click here, path, copy link. It's called number sorting, which is nice. I like the title bubble sorting. So to my friend Matt Bell, good guy. Copy, okay, and then let's take that title and say, okay, there you are, number sorting. And it's nice, this is kind of a copyable little script, which is kind of funny if you think about it. There we go, number sorting. All it needs is a list of integers. Whenever I have that, I just grab a number slider. I put it in here, I do a little randomization. I'll probably put everything over the integer, but just in case you want to see it as a number integer, let's take your gene pool and pop it in there just to force it. And then sorted, that will sort all those beautiful numbers. Nice little note, nothing tricky about it. There you go, all in order. And wait a second, list number sorted. I would expect you to be a little better sorted than that. It's not sorted in the least. 10 numbers, edit. Let's take it down to an integer value. I mean, let's throw a bug in it. But It should definitely be sorted. Why are you not sorting the numbers? Of course, I can't see the script. Why is it running into trouble? So, because I see there's a little error here, some odd reason, bubble sorting exercise, and reset. Oh, that's bubble sorting. Sorting and under sorting. What is going on in that script? That should be sliding through and finding a bigger number for each one of those scripts as it goes through in an array of points. Maybe. No, that's weird. Why would it not? Let's put it in order of what it is. Maybe. Let me try something else. I'm very curious about that. Let's have a series. Let's do a count of 12. Let's put those series are coming out. Let's mess them up with a sequence jitter. And that jitter we want fully jitter, 1.00. So all of a sudden that jitter is putting those values in a crazy order, plug them back in, and it's not sorting them, which is very weird. I have to wonder if it would sort over on this list. Sorted. And it did. So why does it not sort through my hopped up script? Why does it not run? And there is a trouble with C# scripts. I've started to find this problem. I have to look back at my hopped up script and see if it isn't running. And it might be that it's running through the number of items that I chose for it. That's very strange. That's not. Let me sort this one back in order. But it's not working when I run my hopped up. So there's an issue I need to focus on. And I'll try to figure that out. But right now, we'll take that bubble sort. And until I figure that out, that might be reason to call the forum and find out what's going on. There's a problem with that script, not sorting, not running. And I've noticed a little bit of running through C. There's been an issue. So I'm going to bring that to the forum. What I'm going to do in the meantime is group that and say that there's a red warning for me, which I like to do. Here, let's change the color so I can just put a little bit of red and warn myself that something's up with that script. And the last one, which I don't mind jumping on, is, let's go back and see if the script's running a little better on this. And a bubble sort, which I think if the number sort's not working, probably not going to have much more luck with the bubble sort, GH. Download, copy link, put that here, grab in here, path, shoot to that script, run that script, and reset boolean toggle. Let's do that. Yes, reset. Boolean toggle. Yeah, reset. Run. And the values, let's try to gene pool again and see if that will do the same. So let's do that and run that. And then here, in that point sorting, what do those points look like? There they are. Somewhat hard to say if they're sorted. Larger. No, they're not. Which makes me wonder, well, what else was going on here? Exercises, bubble sort exercise, reset. Oh, maybe I need to run it. And hard to say if it fixed or not. Let's get that running. Let's take these numbers. Let's see what's coming out. And same type of thing, true, reset. Okay, reset. I think we've got them in order now. So I think these ones, if I took them the points and saw where they were, I think we'd finally sorted out a little bit and ran in and tried to figure out what was going on. So I believe these points are being a little more in order. These points, however, are not. So these ones are in order, and these ones are not. So there's a problem with running. Yeah, definitely there's a problem with running. I'm interested why. Yeah, sorting points. Very interesting. And there's only a couple points that are running through the gene pool. Maybe I have to flatten the data. I don't think so. I think it's running as lowest anyhow. And I think it might be an issue running multiple things as well. Hopefully I don't have to do that. Anyway, these are the problems that I have when I'm playing with this. I'm very happy that this sorted list is something. This one is this one. This one's with this one. Let's see what happens here and here. Those values are only running out a couple of points again and again, and not even getting through the list. They're only really running. Oh, that's strange. There we go. Reset true. Reset true. Run. Okay. Reset true. And run. Okay. So just interesting. I'm trying to figure this out. I'm curious on a curve. Yeah, sometimes I'm kind of get my head around myself. There's the lines. And let's do reset and true. Yeah. And let's just grab another randomized. That one's trying to organize itself. I see it's coming out in Z. What might help is if I edit this and bring it right down to like a 2 count. And that might allow it to be seen a little more. There we go. That's going to help us out a lot. And so, reset, and then run. And then also, these vertices reset, and run. No, those aren't being sorted at all. Not at all. So interesting. This is the one that actually pulls script works and see I can't get it to work for hops. Alright. Sorry for the slowdown. The same thing goes. Taking this one and realizing those are just not sorting the way I want them to, and put that one over here and say add to group and find out what's up with C. I did hear something in the hackathon that I did. But there could be problems with running that, and I think there might be a couple more problems in here. Anyway, we do have some nice C scripts to start bringing over and hopping to that don't require you to have these C nodes. And I'm going to try to figure out a little more problems as I get into resolving that with Python and C. I hope this is a productive path to end up making it to. I'm just going to take all these and just put them disabled for now. And I've got that other little script that I'm kind of proud of. Enabling that just to build a little bit of funky geometry that's worth kind of staring around at using a couple of nodes in C. And hopefully those C nodes are all working correctly, which I think definitely are before each loops. Alright, going to take a break. I'll leave that for today. I've got to pull in some people to help me out with class tomorrow. Thanks for watching.